curious minds. Welcome to ProjexCellence ProDigy, your one-stop solution for all things project management. I'm Govind, a certified PMP. In today's episode, we will decode the Stacey Complexity Model, a powerful tool that helps you choose the right project lifecycle based on how much is known and how much is not. From simple tasks to chaotic challenges, we will walk through each zone with real world examples and show you why Agile thrives where uncertainty lives. So let's get started. Stacey Complexity Model. Project work exists on a spectrum. At one end, you have clearly defined and predictable tasks, and at the other, you face high level of change, complexity, and unknowns. Choosing the right life cycle, predictive, hybrid, or agile, depends largely on how much is known about what needs to be done, means the requirements, what are the requirements, and how to do it, the technical approach. Stacey Complexity Model helps us make smarter decisions about our delivery approach by looking at two key factors. On x-axis, technical degree of uncertainty means how well do we understand the processes, tools, and technology to deliver the outcome. And on y-axis, requirements uncertainty, how well defined are the requirements and customer expectations. If you see this graph, there are total 4 zones: simple, complicated, complex, and chaos. These are not divided into 4 equal quadrants like a typical 2:2 matrix. Zones are shaped using curves and gradients to show the fluid transition from one domain to another. Boundaries are not strict. Projects often lie between zones, and diagonal movement across the graph represent increasing uncertainty. This curved graph is more dynamic and realistic. It reflects that uncertainty grows non-linearly. It is designed to better reflect real-world project complexity, where work doesn't fall into neat boxes. It shows that the shift from one zone to another is progressive and sometimes overlapping. First zone is simple zone, bottom left corner. If we see here on x-axis, low technical uncertainty means you know exactly the work how to do it, and you have well established procedures, best practices, and SOPs. Your tools and methods are tested, repeatable, and stable. And on y-axis, again here, low requirements uncertainty means you know exactly what to do, and stakeholders have agreed the goals and specifications are complete. No ambiguity in the outcome or scope. So the projects fall under this zone will follow the traditional or predictive approach. Define, plan, execute, and close. Example of such project could be installing street lights in a residential township. So requirements is clear, like number of poles, lamp types, placement points. These all are clearly defined in the drawings. Technology also known here: civil digging, wiring, electrical pole erection as per the standard SOPs. If we see dependencies, minimal or known, and regulations and safety codes are standardized. So you can easily plan the work from start to finish, schedule labor, order parts, and proceed without needing any kind of changes. Second zone is complicated. Here the curve moves rightward more than upward. You can see here the upward movement is very less, almost same to simple, but rightward it's moving towards the high uncertainty. So it means the requirements are relatively clear, low to medium y-axis uncertainty, but the technical solution is less certain here towards high uncertainty. In this zone, what to do is known, but how to do it may require expert analysis, design, or engineering judgment. For example, suppose we have one project upgrading a hospital's electrical backup system. The hospital wants a new diesel generator system that powers the ICU, emergency, and operation theaters during blackouts. And it should comply with noise, emission, and fire safety standards. These requirements are clearly defined. The project team knows what the hospital wants. But for the technical complexity, you need to match the generator to existing building load and wiring. Ensure the generator integrates with automatic transfer switches. And you have to consider safe fuel storage, ventilation, and vibration control. And you have to meet the local compliance codes and safety inspections. So this will need experienced electrical engineers, mechanical designer, and coordination with local authorities. Why this project is in complicated zone? So here what to do is clear, means requirements are defined, but how to do it involves multiple expert inputs, feasibility checks, and sometimes redesigning parts of the plan. You may encounter site specific challenges like space limitations or outdated wiring. So the best approach to handle this kind of project is hybrid. Start with a predictive plan, but stay open to expert adjustments and technical reviews as you move forward. Next zone is complex. Here on x-axis, it's a high technical uncertainty. Means you are not sure how to achieve the outcome. You have new technologies or integration challenges, and it requires testing, prototyping, and learning. On y-axis, you have high requirements uncertainty. You are not sure what the final product should look like. Requirements are evolving with user input, discovery, or feedback. And stakeholders may change their mindset based on outcomes. Let's understand it with one example. Suppose we have one project developing a health monitoring mobile app for the elderly people. So requirements here are evolving. Initial idea may include heart rate tracking, but users later ask for medication reminders, SOS alerts, fault detection, or other features. And technology also medium to high uncertainty. You need to integrate wearables. This means the app or system must connect and work with external devices like fitness trackers and smartwatches like Fitbit, Apple Watch. Another technology challenge could be cross-platform development. Means app should work on multiple operating systems like Android, iOS, and maybe web. In this case, team uses adaptive approach, agile methods like Scrum and Kanban. Customer feedback is essential. Elderly users may give feedback on usability, font size, button placement, which significantly impacts redesign. So the team builds a working version in 2 weeks sprint. They get feedback from the users and then iterates to add or change features. And the last zone is chaos, fundamentally risky. Chaos is not a delivery zone, it's a discovery zone. Why? X-axis, if we see technical degree of uncertainty is very high. We don't know how to build or solve it technically. Tools, methods, or technology may be untested, volatile, or non-existent. And on y-axis, requirement uncertainty also very high. We don't know exactly what the customer or end user wants. Goals are vague, conflicting, or change rapidly. Chaos occurs when both the problem and the solution are unknown or unclear. If you have noticed, it's drawn as a mirror opposite to the simple zone because the simple zone is the most stable and structured, low uncertainty on both axes. The chaos zone is exactly opposite to the simple zone, most unstable and unstructured, high uncertainty on both axes. Projects in the chaos zone are not ready for execution. You must first stabilize at least one axis. Example of such project could be emergency cyber attack response in a utility company. So requirements here are totally unknown. No idea which systems were affected, how deep the breach is, or what customer data is compromised. And technology also unknown. The attack vector is new, possibly involving third-party software or industrial control system like SCADA. So in this situation, the first step is damage control. Shut the system, secure network. Then with more clarity, the team can explore solution in small iterations. So the project approach in this case should be in phase 1, immediate crisis response. And in phase 2, when one axis is known, transition to agile or incremental approach to recover the systems and roll out fixes. And that wraps up today's lesson on the Stacey Complexity Model. We explored how uncertainty in requirements and technology helps us choose the right approach. From linear methods in simple situations to agile and adaptive approaches when things get complex. Remember, not all projects can be managed the same way. The more uncertain your path, the more flexible your process needs to be. If you found this useful, don't forget to like, share and subscribe to ProjexCellence ProDigy. Until next time, Namaste, goodbye, Sampai Jumpa.